This is continuing from yesterday. X to the P of X equals X to the 4 plus 2X cubed minus 7X squared minus 8X plus 12. What are our possible factors if we didn't have our calculator? Because they could just ask, what are the possible factors, not actually what they are. Yeah. And then positive or negative all of them, right? Because those are the factors of the constant. Okay, so we go to our synthetic division. We write down the coefficients, but we have to make sure first that we can count down, correct? We can't count down exponents. We have to put a placeholder, do we not? Okay, so we have 4, 3, 2, 1, 0. When you type into your calculator, what one do you get? Whoever says it first, I'm using yours. X equals what? 2? So 2 is the x-intercept. So then what's the factor? X minus 2. So we always use this same number in remainder theorem and in synthetic division. The x-intercept. Okay. So we drop the 1 and we just do all our same steps. 1 times 2 is 2. Then we add. 2 plus 2 is 4. Then we multiply. 2 times 4 is 8. Then we add. Negative 7 plus 8 is 1. Then we multiply. 2 times 1 is 2. Then we add. Negative 8 plus 2 is negative 6. Then we multiply. 2 times negative 6 is negative 12. Then we add is 0. And we need it to be a 0, correct? Because that means that this is actually the coordinate to 0. Because my remainder is just what? Of a coordinate. The remainder is just the y, isn't it? So this is the coordinate to 0. So it's the x-intercept. We proved it worked. Now it was an x4, so this is going to drop down to a what? An x3. The reason why is we pulled an x out already, right? We pulled this x minus 2 out, so now this one's going to be an x cubed. So we have 1x cubed plus 4x squared plus 1x minus 6. If this was a question yesterday, if I asked you to factor that yesterday, what would you do? What would have been the first step? Type it. Where can you type into? Only one object in front of you that you can type it. Your calculator. Yes, you would type it into your calculator. It would just be like if I gave you an x cubed equation, right? Type it into your calculator into y equals, and give me a what? An x-intercept. Grady? 1? So we get x equals 1, and then we'd have x minus 1 as our factor. Drop the 1. 1 times 1 is 1. Add it. 4 plus 1 is 5. Multiply. 1 times 5 is 5. Add it is 6. 6 times 1 is 6. Add it is 0. And then it drops down by 1 again. X squared plus 5x plus 6. What can I do with this? Factor. So I say what times what equals 6. And then what plus what equals 5. Some people will tell me 6 and 1. 6 and 1 gives me 6, but 6 and 1 gives me 7. So that's not going to work. So it's not 6 and 1. Yeah. 2 and 3. And I can go right to brackets because I have a +1 in front. If I didn't have a +1 in front, I'd have to do decomp where I replace that middle term like we did yesterday. So we're going to get x plus 2, x plus 3. So in the end, I'm going to write p of x, because that's what it was, equals what? What are all my factors? X minus 2, x minus 1, x plus 2, x plus 3. If we want, we can do a quick check. If you multiply all the front of these, you should get the first term. So x times x times x times x is x4. Okay. If you multiply all the back of them, you should get the constant at the back. -2 times -1 is 2, times 2 is 4, times 3 is 12. 12. If you wanted to check the whole thing, you would actually literally have to FOIL, distribute, collect like terms. That would take forever. But if you want to do a quick check, you could do this. Another quick check you could do is type the original into your calculator, type this into your calculator in this form, and what should you get? The exact same graph. If you didn't, you messed up. Sometimes the mess up is literally in when it's a decomp, people just go right away and put it into brackets, and you can't, you have to do decomposition. So when you type the original in and then you type all these in, it doesn't match because you forgot to do decomp. These are called linear factors because they're factors and they're each of the shape of a line. Okay? Linear factors. So if I gave you an x to the 5, what would you have to do? Synthetic division, get me to x to the 4. Type it in my calculator. Synthetic division, get me an x to the 3. Type it in my calculator. Synthetic division, get me to an x to the 2. And then factor. It's just one extra step. Okay? So if I ask you to factor, this is what we do. We agree? Yes? Okay, what if I ask you to factor? I'm going to pick a specific one. And then we're going to solve it. Okay, factor this. And I'm picking an x cubed because honestly, if I give you an x4 or x5, it doesn't make the question harder. You just have an extra step. Like it doesn't make you do any other crazy thing. So say I say factor p of x equals x cubed plus 4x squared plus 3x minus 2. Try it out. Go. What x-intercept works? X equals, what'd you get? -2. So my factor is x plus 2. And I check 3, 2, 1, 0, so I'm good. If you do the synthetic division and you don't get a 0 as a remainder, often you just forgot a placeholder. Like often you're just missing a 0 because the x cubed is not there or something, okay? So always go back and make sure you have your placeholders. So we drop a 1. -1 times 2 is -2. Add it is 2. -2 times 2 is -4. Add it, -1. -2 and -2 is +2. Add it is 0. I specifically picked an ugly one just to see what you do. So x squared plus 2x minus 1, because it's always 1 less than the cubed, right? And we can't factor it, can we? No? So actually, it's an easier question because p of x equals 1 linear factor and 1 quadratic factor. So if I said factor, this should bring you joy. If I said solve, this is not going to bring you joy because you have to use the quadratic formula. Yeah, that's when joy doesn't come back. Okay, so factor, we're done. Now what if I said solve? Well, we take our things, our factors, and we set them equal to 0. That's how you solve. That's what we learned in grade 11. So we go x plus 2 equals 0. And we go x squared plus 2x minus 1 equals 0. This one's easy. You just subtract 2. So I have one answer. That's my one x-intercept. This one isn't as easy. If I say exact values, can you give me decimals off your calculator? No, exact values is not decimals. If I say exact values, can you, if I ask for exact values, you can't give me decimals off your calculator. And if I ask you for solving algebraically, you can't give me decimals off your calculator, right? Because you have to show me work. So, quadratic formula. It even says, it's very top left of your formula sheet, it even says for ax squared plus bx plus c, it tells you what order it needs to be in, and which is a, which is b, which is c. So a is this one. So a equals 1, b equals 2, c equals negative 1, and then we have to put it into x equals negative b plus or minus the square root of b squared minus 4ac all over 2a, the whole thing. You don't need to memorize it. It's on the very top left of your formula sheet, so please don't memorize it. There's no point. So we go x equals negative, b is 2, plus or minus the square root, b, which is 2, squared, minus 4, times 1, times negative 1, all over 2 times a, which is 1. So we literally just fill in our numbers, right, for the variables. The next thing you do is you do what's underneath the radical. So you go negative 2 plus or minus the square root of. Now, we do this together, so we're going to get 4. Then we multiply these 3 together. Negative 4 plus 1 times negative 1 is positive 4 over 2. So we get x equals negative 2 plus or minus root 8 over 2. Then we bring back grade 10. Root 8. What can I break root 8 into? What perfect square? What can I break 8 into? What perfect square? 4 and 2. Why would I break it into a perfect square? Because if I can get a perfect square underneath this radical, I can take it out by square rooting it, correct? So it's the square root of 4, 2, and then it's gone. So it equals 2 root 2. And I go back here and I replace it. X equals negative 2 plus or minus 2 root 2 over 2. And then it's an all or nothing thing. If you can take a number out of this coefficient, this one, and this one, you do it. If you can only take it out of these two, or the top two, you're stuck. Okay? It has to be all 3 numbers. So I can take a 2 out of all of them. This one I'm left with a negative 1. And even if it was a positive 1, I'd have to keep a 1 there, because you're going to go 1 plus or minus something, right? Which is different than 0 plus or minus something. So if the completely canceled off and it's a positive 1, I'd have to keep a 1 here. This becomes a 1. This becomes a 1. Do I need to keep the 1 in the denominator? No. So I'm going to get x equals negative 1 plus or minus root 2. So when I go to write my answer is x equals negative 1 plus or minus root 2. Those are 2 answers, correct? Negative 1 plus root 2, negative 1 minus root 2. So there's 2 x-intercepts there. And negative 2. So if it says factor, and you get a quadratic that doesn't factor, happiness, because you don't have to factor. If it says solve, and you get a quadratic that doesn't factor, it's not nearly as happy because you have to use the quadratic formula. Does that make sense, the difference? Can't factor, I'm done. Asked to solve, I have to keep going. Okay? Because solve means, in the end, what does x equal? What is your variable equal? Whenever it says solve in any math class you were ever in, if it says solve, it wants to know, hey, here's a variable, tell me what it equals. That's what solve means. Okay? So I'm going to get you to try a couple. I'm going to get you to factor first as part A, solve as part B. Okay? And we literally only have like a lesson and a half left in this unit. That's how short this unit is. They have to be short when you have 11 chapters, right? Okay. A part, oh, A. P of x equals 12x cubed minus 16x squared minus 7x plus 6. I want you to do part 1, which is factor, and then part 2, which is solve. What happens if you solve and they ask you to factor? What happens if you take those factors further and you do more? It asks you to factor and you solve. What do you think might happen? Did you do what they asked you to do? No. So actually doing more is not always a good thing, right? So if they ask you to factor, you have to stop because that shows them that you actually know what the heck factor means. If you go to solve, you're not showing them you know what factor is. You're showing that you're going to just give everything you possibly can and hope that they give you a mark for factoring. So it says factor, you can't keep going, okay? Please don't keep going. But I want you to factor, then solve. That's A, and then this is B. And then I'll give you a C after for practice. Before we move on though, before you start attempting, the reason I picked B is because people get stuck on B all the time. What are the possible zeros of B? Is there a constant at the back? A constant is a number without a variable. Is there a constant at the back in B? No. So then people are like, well, there's no possible zeros. If there's not a constant and you're like, oh, there's no possible zeros, that's a hint that you need to take an x out. So look, what does this one have? X4, x cubed, x squared, x. They all have an x. So our very first step when we go to factor this particular one, is we have to take an x out. So we're going to get x, and then we're going to get 8x cubed minus 12x squared plus 6x minus 1, right? You just see I took a GCF out, that's it. Here, I have one factor already, x. How do I keep solving this now? How do I keep going? Synthetic division with this x cubed. Okay? So I would get one factor as x, and then I have to do synthetic division with this. And then when I go to solve, I can't forget that this one has to solve as well. Okay? So try that out. So if they're all x's, you have to take an x out first. It's a trickery kind of thing. We do the half. We get 12 minus 16 minus 7 and 6. Drop the 12. Half of 12 is 6, add negative 10, half of negative 10 is negative 5, add negative 12, negative 6, 0. 12x squared minus 10x minus 12. You can use that, or you can take a 2 out and knock it down. Either way, it'll still work. So you get 36, so it'd be 6x squared minus 9x plus 4x. Don't freak out if you didn't do it this way, you'll still have the same answer. Take a 2 out. Left with a 3x, and you're left with 2x minus 3. Take out a plus 2, and you're left with 2x minus 3. And so we get 2 times 3x plus 2 times 2x minus 3. You might have, if you forgot to take it out, you might have 6x plus 4. Or you might have 4x minus 6 instead, like if you didn't take the 2 out like I did. But at the end, when you have that, you have to take the 2 out. Okay, so if you have 6x plus 4, you need to take the 2 out and have 2 times 3x plus 2. If you have 4x minus 6, you need to take the 2 out and have 2x minus 3, the reduced form. Okay? Does that make sense if you're at that point? Because if you didn't take the GCF out, you would be at that point. So P of x equals 2, 3x plus 2, 2x minus 3, and 2x minus 1 from the top. Boom. If I said factor, I'm done, right? I don't go on any further. I do not solve. I do not press go. I do not collect $200. I am done. Yes? 2, I would keep going. This 2, does it have a variable on it? Is there a variable with this 2? No, it will not get you an x-intercept. Okay? It's imperative. This is why I'm going to make you listen. The 2 is important that we have it because I take the 2 times the 2 times the negative 3 times the negative 1 and it gets me my y-intercept because this 2 is a vertical stretch, is it not? Yeah. What? 2 is a vertical stretch. You need to repeat it or replay it. It was done. Okay. So the 2 in the front is a vertical stretch. So what does it affect? My y's, like my y-intercepts, correct? Does a vertical stretch affect my x-intercepts, though? Because it's x's? No, please do the transformation review. For all y'all who are like, I have no idea what you're talking about. Transformation review. Come in at lunches. Visit me. I'm friendly. Okay, so this is not going to affect it. So I'm going to take this, and I'm going to go 3x plus 2 equals 0. 2x minus 3 equals 0. 2x minus 1 equals 0. And then 3x equals negative 2, divide by 3, x equals negative 2/3, 2x equals 3, divide by 2, x equals 3/2, 2x equals 1, x equals 1/2. Yo. Yeah, it would still work for your x-intercept. You wouldn't if you was solving. If it said factor and you didn't take the 2 out, they'll probably deduct just because you didn't pull out, didn't GCF it enough. But if you had left it in, you would end up moving a 4 over and then dividing by 6 or whatever, and it will reduce the fraction to the same as what this is. So you'd be okay. Because this 2 doesn't affect your x-intercept, right? That's what I was saying. So say you had 6x plus 4 instead, right? You'd subtract the 4, and then you divide by 6, which reduces to negative 2 over 3. So it won't affect your solving. Yeah, but like, if I got negative 4 over 6, yeah, you need to reduce that. Like, I don't know what they would do if it was a written response, but a multiple choice would be negative 2/3, so you'd catch on, you need to reduce it. But just always reduce. It's proper math. I don't know if they would actually, I don't know. Okay. And then this one, you would just factor this spot, and when you factor, oh, where did I put the book? When you factor it all out, just for ease of time, you would get x, and then 2x minus 1, 2x minus 1. And then you would get this. Pay attention. X equals 0 for solving. And x equals 1/2. How many of them are there? 2, correct? 2 halves? So if I just put 1/2, does that tell me that there's 2 halves? Is there a remnant that there's 2 halves? Is there anything telling me there's 2 halves there? Because it makes a difference. We'll see, because you got a tangent. So what you have to follow behind with it is multiplicity 2. If there was 3, you'd say multiplicity 3. I know, exciting, right? Like, great word. Yeah, awesome times. That's what it is. Enjoy. All right, so I'm going to give you guys some questions for homework.